Hello, my name is Magda Cuello. I will be demonstrating how to solve a mathematical problem using a tool modeled after Bollia's four-step approach to problem solving. The CUBS math strategy is an acronym which I use in my first grade classroom. My first grade students have memorized and applied to this acronym to solve story problems. It has given my students the freedom to construct their own mathematical understanding and has helped me support and extend their thinking. This slide illustrates how CUBS aligns with Polya's four-step approach. In Polya's first four-step approach, the first one is understand the problem. What is being asked? What do the terms mean? What is known? This correlates with the letter C and the letter U. C for circle the key numbers and units. So what is being asked? U, which is underline. Again, what is being asked, the question. And again, going back to C is what is known. You know the numbers when you read the question. You know what the units are when you read the question. Number two in Polya's four-step approach is devise a plan, which is draw a picture. That goes with S, show your work and check. Okay. Number three in Polya's four-step approach is carry out the plan. Try different approaches. So that again goes with S, which means show your work and check. Show different ways to solve the problem. And four, in Polya's four-step approach is look back. Did you answer the question? Double check, which is S in show your work and check. One that I forgot to mention is boxy action words, which goes with number one, understand the problem. In this video, I have simulated a guided math lesson using CUBS to solve a story problem. The first step to solving a story problem is to read the problem. There were 3 frogs sitting on the log. 4 more frogs hopped on the log. How many frogs are on the log now? What does the letter C stand for in CUBS? Yes, C stands for circle the key numbers and units. What numbers do you see and hear as we read the problem? There were 3 frogs sitting on the log. 4 more frogs hopped on the log. How many frogs are on the log now? Correct. 3 and 4. We will circle the numbers 3 and 4 with a red crayon. Just like it is in our poster, you circle the numbers or the units in red. Okay. Now let's go on to U. What does U stand for? Yes, U stands for underline the question. The question is, how many frogs are on the log now? Underline the question with your orange crayon. Good job. B stands for box, meaning box the math action words. Remember, action words are things that we can do, verbs. What are the action words? Yes, sitting, which is on the log, and hopped, which is hopped on the log. Box the words sitting and hopped with the blue crayon. Good job. Now, what does S stand for? Yes, S stands for show your work. What numbers did we circle? We circled numbers 3 and number 4. What do these numbers represent? Yes, they represent the number of frogs. Now let's reread the question. Remember, the question is underlined in orange. So here it is not underlined, but it would be underlined in orange. How many frogs are on the log now? We need to find out how many frogs are on the log. What are the action words? Yes, the action words are sitting and hopped. What was sitting? Yes, 3 frogs were sitting on the log. Let's draw 3 frogs on the log. If you can't draw a frog, draw 3 circles on the log. Write the number 3 on top of the frogs. The other action word is hopped. How many frogs hopped on the log? Yes, 4 more frogs hopped on the log. Draw 4 more frogs on the log and write the number 4 on top of the frogs. How can we find out how many frogs are on the log now? Yes, we can count them all together. That means add 3 plus 4. Let's write the addition symbol. Remember to write the addition symbol in between the 3 and the 4. Now let's count all the frogs on the log. 1, 2, 3, 4, 5, 6, 7. Yes, there are 7 frogs on the log now. Let's write the equal sign and the answer, which is 7. We can check to see if we got the answer correct by using the number line. Circle the number 3 on the number line and jump forward 4 times. 1, 2, 3, 4. Circle the number you stopped at. Yes, the number 7. The answer is correct. 7 and 7. There are 7 frogs on the log now. Now let's write down what we did to solve the problem. First, I drew 3 frogs on a log. Second, I drew 4 more frogs on the log. Finally, I added 3 plus 4 and counted 7 frogs altogether. The answer is there are 7 frogs on the log now. Of course, you would have this sheet blank, and each student would have a sheet of their own. And at first you would model, and then you would have, this is guided practice. So this would be guided practice. You're doing this as the students are doing it with you. So they will do all the things that they need to do to solve the problem, and then they would answer what they did to solve the problem. So one of the things that I wanted to let you know that it's very important to teach students how to solve math problems in multiple ways. Number lines, help to provide a mental strategy for addition and subtraction. Research has shown that number lines are important because they promote good mental number sense and arithmetic strategies. They add a visual element to the numbers and allow students to break apart and put numbers back together. Take the above example. Children start out by counting on fingers from 1 to 3. Then they count 4 more to get 7. There's nothing wrong with this method. It's a natural stage, but there's a bit of needless counting going on. They're gonna realize this and start at the 3 and count on to 7. Number lines are a great way to accelerate this development. Learners soon graduate from using simple number lines to visualizing one in their mind. This is when the number line has done its job. I hope you enjoyed my video demonstration. Thank you.